Good morning. I'm glad you guys decided to wake up early this morning and join me here. I know this is early for me. So this session here is all about using AngularJS, JavaScript, with ASP.NET and basically building rich applications that you can build inside the browser to kind of do the things that maybe you didn't think you could do in the browser, Chrome, IE, Firefox, etc. And I'm going to show a couple different kind of demos along the way to show you some things that I kind of wish I knew when I got started. So first, one of the things with Angular, when you first get going with it, is you realize that the reason it was successful and it's really taken a meteoric rise out there in the JavaScript world is a theory I call the gamification of AngularJS. You feel like you're getting results quickly when you use Angular. So it's like this reward system or achievements as you move along. Within 2 lines of code, you can get something running very, very smoothly. But then you hit some walls along the way. So you get that kind of emotional roller coaster where it's like, all right, I just made some really cool progress, but now what do I do with this particular situation? So this session here is all about how do I get past those walls? I've learned Angular, but now I need to get past those beginner steps and take the next one to apply it to real business solutions. So my name is John Papa, and I'll be talking about AngularJS on ASP.NET and show a little bit of Node as well, just show you how you can do this cross-platform. And we'll be going over 10 Angular tips that I wish somebody had told me more about when I got started. So with Angular, as I mentioned, when you get this productivity scale over time of kind of your emotions go up and down. And first of all, you're like, wow, this data binding stuff drew me in, and it really is awesome. But then, well, wait a minute, slow down because I have some issues and I can't figure out how to get past some other things. And after a while, you're like, oh, geez, this is really cool. Dependency injection is awesome. And then you're like, uh-oh, wait a minute, man. Nobody will notice if I switch back, right? Silverlight, where's that thing? So at the end, hopefully, you're feeling like I do and Angular rocks. But if anybody tells you that this is a smooth ride and everything's wonderful and roses along the way, it's not. It's like any technology. You have to learn the bumps along the road and figure out how to navigate those. But the good thing is, again, you get that gamification, that constant reinforcement that the things you're doing are working for you. So when you're building something beyond the to-do app, all those little one-page to-do demos we see with Angular out there or other technologies that are so simple, when you get beyond those, there's some other things you have to take into consideration. And building large-scale apps does require some forethought. So I'll mention this at the end as well, but all the demos you're going to see today will be available up on GitHub at this URL here. Actually, most of them are there. I think they're all there already. I've got about 10 demos to show you. And then if you want to check out deeper content on these topics, you can check out my courses at Pluralsight. And the Pluralsight folks are actually here in the vendor hall. They give away a free month, so definitely check that out and get a free card from them. And then there's some other tools that I'll be showing. For example, this NGZ whip in my last demo. It's actually an open source library I wrote to help it make it easier to work with local storage and Angular. So you can download those. And here's the topics we're going to be covering. We'll start off with how the components fit in. It's kind of a little bit of a rehash of the basics of Angular, but kind of figuring out, okay, now I know all those puzzle pieces, how do they fit together? And then we'll go through a bunch of different features that allow you to kind of get started and get going quickly. And then we'll talk about some more business case scenarios of how you can apply things like having a global exception handler to handle all of your crazy cases inside your code. So how do they fit together? First of all, it's really important to know which thing you need with Angular. Do I need a factory or a service or a provider or a constant or a value? There's all these different things in Angular, and knowing which one you need is really important. And when you're getting started, the first thing you see is a controller and a view. You put your data together, and it's easy. But let's kind of look at how all these pieces fit together. First, you can think of a module in Angular as basically an app or a self-contained unit of functionality. All the things that you're going to use in Angular kind of exist inside of this thing called a module. Maybe you can think of it like a namespace in .NET. Similar. And then inside that module, you're going to have more than one view. Most apps have more than one screen, right? So in that module, you might have routes to get to those views. Routes are just navigations to get to those different places. So maybe I've got these views and controllers. The view is my HTML. The controller is my JavaScript. Just fancy names for putting these things together. I might have a view that shows me a list of people, and then the controller that actually gets that people information and binds it to the screen. Which brings you to binding. There's this $scope thing in Angular. And if you haven't figured it out, all the services in Angular start with the $. Why? Because Angular's money, right? No. They actually get royalties, I think, every time you use that. But the scope is the thing that binds the controller to the view. So it gives you that data binding glue. So anybody here done XAML in the past? Lots of you? It's data binding. It makes it a lot easier to get that data back and forth. And then inside the view, you're going to use things called directives. So there's a lot of things in views that you're going to want to reuse. Maybe you're using a third-party widget from some company like Kendo or Infragistics or DevExpress. And you can actually take those controls, and they have things called directives, which is basically like an HTML tag that you can plop inside your view to reuse those across multiple views. So it's like reusable widgets. Those are directives. And then in the controllers, you might have features that you want to share across multiple controllers. For example, I might have 5 different views and controllers that handle showing information about a customer, but in different ways. But each one of them is getting the customer name. I don't want to have the customer name logic in each of those controllers, so instead I write a service or a factory. You'll hear me use those words interchangeably. So a service or a factory will allow me to go off and get that data, and then I can have all my 5 controllers called at one place. It's just the solid principles. So these are the basic components and how they fit together inside of Angular. And here's some notes for you in the slides to just further reiterate this. In the view, you'll see things like these built-in directives. Anytime you see ng dash, that's an Angular directive. You'll see things like click. That's how I bind a function to click on a button over into my controller. Ng model, that's how I bind a value. And then we've got the controller itself. To set up a controller, you put it inside of a module. Notice here we've got an Angular module called app, and then inside of there we're creating a controller called Avengers. And that's going to handle all the presentation logic for my view. I'm not going to put any of that inside the view. I'm going to put it in the controller. That's what his job is. And then that $scope thing, that's the glue between the controller and the view. So in this case, here's my controller, and I've got this VM dot thing. That VM is my view model or my scope. I like to use the word view model because I come from that XAML world. And so I've got this view model thing, this scope, which allows me to put properties on it, like Avengers. I'll have an array of Avengers in my controller that will now be accessible inside my view. So anytime I add or remove something from that Avengers array, it'll show up or disappear inside of my view. And then we get to modules, which are a really important part of beyond the basics of Angular, because there's going to be features you want in your application that maybe you didn't write or someone else in your team wrote, and you want to plug them in and just make them work. So modules are a way of injecting functionality into your application from different containers of features. So here we've got a module called app, and the second parameter to the module is going to be all the dependencies for it. This says, before you create that app module, go off and get the ng-animate and ng-route modules. That gives you features baked into Angular for routing and for animations. And then go get these other ones for UI Bootstrap. I want to use Bootstrap with it. And get these things called common that I wrote. And those are my particular modules. So you can take and create your own models and plug them in. And this is great for team structures. So maybe a couple of people over here can write their own modules, put it together. Maybe they wrote the common one, and they can just plug it into the code that the people over here wrote, and it just works. So modules are a great way to build and actually put out code like on a monthly basis or any kind of iteration schedule you have. So kind of like a DL, but not really, right? And then routes. So we get going with our application. We've got to tell it when you go to this URL, go to this particular view. That's all routing is in a nutshell. So I tell it when I go to /Avengers, go find the HTML file called avengers.html. And we use this thing called a route provider, again, the $, with Angular to get us there. And then built-in directives. So how do I actually make a button click call some functionality inside my controller? The way you do that is with like an ng click. Anything you see with ng dash, that's an Angular directive. So I'm saying here, when you click on this button, call inside my view model a function called refresh. So this assumes there is a function called refresh inside your view model, of course. But this is how Angular extends HTML, so you don't have to put JavaScript inside of your view. You can put it right inside the controller and leave it out of your view's domain. There we go. And the last piece of this is the factory. And I really like factories. They're services. Basically, you use a factory to create a singleton instance inside of JavaScript of something you're going to share across multiple views and controllers. Because once you get beyond, again, the 1 or 2 controllers in your app and views, you're going to start realizing that there's stuff you want to share between them. You're going between different pages, and maybe something you did over there, it's not a parameter you want to pass, but it's just data you want the other controller to know about. Well, a factory can do that for you. Factories will give you shared instances. Controllers always new up. So every time you create a controller, you're getting a new instance. In a factory, you're always getting a shared instance. So examples of things I use this for are like a logger in my app, if I want to log out any functionality or instrumentation. Local storage. When I talk to local storage, I create a service for that. Maybe talking to data services. Always have a data service factory that I use to go and talk to HTTP over XHR. So here's an example of a data service that I could write. This one here, called data service. I'm injecting in an Angular service called $HTTP. If you're familiar with jQuery and Ajax, $HTTP is basically the same exact thing. It allows me to do an HTTP GET. And you can see the functionality down there, just HTTP GET, go to that URL. So this way I'm wrapping up all of my functionality for my data calls inside of one service. So now my controllers can just call dataservice.getAvengers. It doesn't have to know how to go get them. It just knows this guy here knows how to get the data. My controller doesn't have to have that knowledge now. So that's kind of how all the pieces fit together. And once you get beyond this and you start putting things up, you start realizing there's kind of a lot of pieces to get going with. I mean, there's more than this, but this is the core set. So how do you get that jump start? And that's where tip 2 comes in. So I've got this thing I wrote called Hot Towel because I've written a lot of Angular apps, and really getting started with Angular, I was like, I hate looking at a blank screen. That's the wrong quote, right? There you go. So getting started should be easy, but it's not. It's never easy, right? Who likes looking at a blank canvas on the screen? I know I don't. So let's remove some of that friction and do that. So what do we want in a project template? Well, we want all the CSS and fonts and things just to be there. I'm not a designer. I don't pretend to be one. I just want that stuff to kind of jumpstart and get me moving. I want Angular in my project, and any other third-party vendor scripts that I might be using. jQuery, Bootstrap stuff, whatever, Toaster. And then I want some starter files. Give me the basic files in Angular, the module itself, a controller and a view and a service, and kind of wire up the basics for me. But also, I draw a line there. I don't want it to give me too much, because the last thing I want to do with the project template is have something start and generate a project for me, and then have me have to go in and rip half the stuff out to put my code in. So it's a balance in there to get me going and give me enough so the app works, but don't leave me in a state where I'm ripping out half the code. This is what Hot Towel actually looks like when you use it. So we're going to do a quick demo here, and this is where you can get Hot Towel. You can either get it from GitHub. It's actually up here in this resource, or you can just use NuGet to do it like this. So let's flip over to my demo. So inside of Visual Studio, we'll do it right here. We'll create a new project. And nope, we're not going to create a node project. That would be bad. Let's create a web project, and it'll be ASP.NET. Once we do that, let's create an empty project. We're not going to check anything off. No, I do not want to do that. Thank you, Azure. So once we create this guy, it should have nothing in it other than basically the project file. And you can see that up here in the corner. There's nothing there but my web config. So now I can go to the NuGet Package Manager, which you can do through the UI, or you can come down here to Other Windows, and we can select the Package Manager console, which will crank up at the bottom of the screen. And down here, I'm going to type in Install Package. There we go. And then I can type in Hot Towel. Let's see if IntelliSense works for me. Hot Towel Angular, there we go. And if I've got a good internet connection, we should be able to pull this all down and load it right up for me. So it's getting a couple things there. Let's see if I can zoom in and show you what it's getting. So down here we see it's getting a couple of Angular features. It's also getting Bootstrap. Now we're getting Moment. Moment is a date library. So dealing with dates really stinks. I've been spoiled for years. .NET makes all this thing really, really easy. But doing all that's really simple with Moment. So Moment's a great date library. And then I also use Font Awesome, and that gives me the nice fonts in there. And then I also use Spin.js to help me get a spinner up on the page. And then Toaster for my plugins. I've got a failure there. Let's see if we can fix that. And let's see what we got. So over here on the right-hand side, you can now see we've got all of our font files. And then we've got our scripts. And we've got our CSS content. And since we had a failure for this one, let me go to show you another project that actually runs this. It's always good to have a backup. So once you get Hotel up and running, you get an app that kind of looks like this. It only has 2 menu items on the left-hand side. It's got a dashboard and then one other item. But it gives you that basic wiring to kind of get you going. So you don't have to worry about getting the modules set up or getting the routing moving. And you can see that I use this for multiple applications too. So if we look over here at this guy, let's see. So we look over here at this guy, I can run him. And you'll see basically this is what you end up with. You get 2 menu items on the left-hand side, you get some toasts in the bottom to give you alerts, and I get 2 screens that are wired up to the application. So I can flip back and forth, and I get a little bit of animations that go with it. And then if I can type in my URLs, we can go to different pages. So Hotel kind of gets you out of the gate with NuGet, as long as your machine has permissions to do so, which mine obviously didn't. All right. So that kind of jumpstarts you. But then again, once you get all that working, this is where the next 2 tips kind of get you out of some trouble later on. So I work on a lot of large teams. And in those large teams, coding patterns are really, really important. So productivity and maintainability are a huge reason to have coding standards inside your code. For example, each component I write always has one job. The place I've gotten in trouble in the past, when I've written JavaScript 10, 15 years ago, was I'd have 6,000 lines of JavaScript in one file. That's kind of hard to maintain, kind of hard to test. Functions would be long. It's basically function spaghetti code. I like to think of it more like raviolis instead of spaghetti. I have these small individual units of code that are wrapped up and have little bits of functionality with one job. Inside of each ravioli or component, they do one thing. So here I've got a data context factory. And that guy is going to handle all the data calls for my application, getting data and saving it, for example. So I expose my functionality at the top. This is an important piece of the code I like. So inside your code, you're always going to have an interface and details. And by an interface, I don't mean like the iInterface stuff in .NET. I mean the things that you're going to be able to call from it externally. So when you call this data service, this data context, you want to know what methods and functions and properties can I access on it. So as soon as I open the file, right at the top, I want to see 2 things. I want to see the name of the service, data context, and I want to see what does it expose. So the first thing I expose, right at the top, is that var service, and then I list off, okay, returning an object from this guy that's got a method called getData and a method called save. Just by looking at those, I know what those functions do. I don't have to scroll through the other 500, or hopefully not 500, 100 lines of code inside that JavaScript to figure out how it works. So I don't list function, 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 function at the top. I put the implementation details at the bottom below my return statement. And this might sound like a little thing, but when you're working on a large project with a lot of people on it, it makes it easy to quickly see what does this guy do. So it's instantly going to be identifiable using this kind of thing. And I call this the above the fold. When I look at my code, everything above the fold is going to be easily recognizable. So how do you get to this point? Well, in Visual Studio, again, I find myself not wanting to recreate the wheel, so I have some templates that I put up into a project that Mads Christensen created called sidewaffle.com, which allows you to get started with Angular pretty quickly. You can basically right-click then and just say, create a new Angular module, create a new Angular controller, create a new Angular directive. So it gives you the boilerplate stuff that you're going to need to get there, and it uses that format that I just showed, where it bubbles all of the interface stuff up to the top. If you're using WebStorm, I've also got links to files that do the same thing over in WebStorm on a Mac. So these kind of things are pretty easy to do into the tooling that we've got. So let's take a quick look at those. So let's say I'm inside of this project here, and I want to right-click on it. Really, where's my mouse? There it is. When I do that, I want to add a new file. I'm going to say add a new item. And then up in here, I can type something in for once I've installed Sidewaffle. I can just type in Angular. And once I do that, look at all the fun stuff I've got. So you got TypeScript, and you've got JavaScript versions. And up top, we've got the JavaScript version, so I can create an Angular controller, a directive, a factory, or a module. Now, there's two syntaxes for creating controllers. There's one with scope, and since I don't like the $ scope, I use the controller as, which we'll be seeing throughout this. It's kind of the new way of using controllers. So let's just create one of those guys. We'll just call it controller for now, just to show you the syntax, and bam. So now you get that basic structure kind of out of the box. But this is the syntax to create a controller, and in here I've got a single property called title and a single method called activate. So it shows me how to create a controller very quickly. Now, how did I get to this point again? That's where I go to Sidewaffle. I love the names these guys come up with things. I'm not sure exactly what a Sidewaffle is, but Mads told me the story one time that they were eating breakfast somewhere, and they had the idea. So if you go there, you can get this, and it's not just Angular templates. There's all sorts of other things here too. Durandal, jQuery, basic JavaScript, ifs, things like that. So anytime you want additional file or project templates, Sidewaffle is a great way to go get those in Visual Studio. Cool. I don't do any programming in Angular without these templates. And it really helps make consistent code across projects. So here is the #1 question I get with Angular all the time. How do you structure your project? I'm not building a 2-page app or a 1-page app. I'm building one with 50. I might have multiple modules. Should I have multiple modules? How do I organize this thing? So I've written a blog post about this, which you can check out here. But in short, my guidelines for you are this. And this is not just for Angular. It's for any code. I call it the lift principle. First, I look to make sure that locating my code is simple as can be. I got to be able to find the code I'm looking for. I worked on projects in .NET that have had 120 projects in a solution. 120. And none of them were small. And trying to find the code, even with all the tooling, is difficult. So naming becomes important and structure becomes important. And it's really difficult to move things once you structure them. So I first try to make sure that it's really identifiable to me and my team of how to find the code. Now, that doesn't mean the way it's identifiable to me is the way it is to you or to you. Find a way that works for you. The second principle I follow, and these are in order of importance, is identify the code at a glance. When I open up the code file or I just look at the name of the file, I should know what it is. I don't like naming files factories.js. Yeah, that's great. What factories? What are they doing? Give me a little bit more love, you know? Identify my code. Foo doesn't work for me. And then F, a flat structure as long as we can. So have you ever gone to like a shopping site and you're trying to hover over the menu and it's got a drop down with another drop down with another drop down? By the time you get 3 levels down, first of all, you're frustrated, and then your mouse doesn't go over it and it just goes back to the top. That happens, that's really difficult to navigate. I've seen that same kind of thing in Visual Studio where we end up having 8 levels of folders to try to find our code. It's a lot easier to find it in a flat structure. In general, my rule is once I get beyond 7 files in a folder, it's time for a new folder. And there's a break-even point somewhere for you. You got to figure out what that number is. Some people like it at 4, some people like it at 10. But figure out what that level is for you, because diving down into other folder structures does slow down your productivity. Plus, it makes it harder to see it all in Solution Explorer. And then T. This is for T-dry. I try to stay dry. I like the do not repeat yourself principle, but it's not as important as the others, meaning if I need to go ahead and modularize something and pull it out, I'm going to do that. So in this order, I kind of follow along, and this is how I design my Angular apps. And there's 2 ways that are really predominant in the industry. One is by type. So here is a 7-screen app shown in Angular, and you can see here by type, all the files under the app folder are in the controllers folder. And then I've got a services folder, and then I've got a views folder below that. So based upon the thing that I'm looking for in Angular, whether it's a controller, a view, or a service, or a module, or whatever, I'm going to go into that folder first. Well, the problem with this structure is once you get into an app that's got 50 screens, you've got 50 things under there. So then you start having to nest those and keep going further. And it's kind of hard to find. And let me give you an example why. So you're looking for, on a project, to make an enhancement to a screen that's called speaker details. Well, if you're going to do that, you're going to have to go find speaker details in the controller to change the code, and then you're going to have to go to another folder called View to go find the speaker detail HTML. So you're going to be toggling back and forth quite a bit when that's what you're working on for the next 3 days. So you'll be going back and forth in different folders, which you've got to navigate to. Wouldn't it be easier if everything you were working on, services, directories, services, factories, controllers, the view, are all in the same place? And that's the one reason I like doing it by feature. So when I organize by feature the same project, now if I'm working on the dashboard, I go to the dashboard folder, and everything about the dashboard is right there. That's that feature. So I can assign that to Joe. Joe can work on the dashboard. And then I can go work on the layout with the sidebar and the top nav. And then I can have Mary go work on the person information. And each one of those has got their own area to work in the code. Either way, we're splitting things out into the same files. It's just the kind of way you organize them. These are two different extremes of working with Angular, and you'll see some other variations. I show them along the way. But a very good friend of mine, Dan Wallin, and I really agree on this. If somebody ever says you're doing it wrong, just go away. He says ignore them. I think he actually used stronger words, and so do I. You're not, okay? Any way you organize your code is fine with us. It's fine with you. It's got to work for your team. Because remember, the browser doesn't care. This is a structuring your code. It's purely for development time experience. The browser has no cares in the world at all on how you structure your code, because when it gets to the browser, it's usually going to be bundled and minified anyway. So pick what works for you. So we showed by type, and we showed by feature, but there's also that somewhere in the middle. So somewhere in the middle might be you might organize by feature, but maybe your feature is getting kind of big, so inside of that feature, then you also do it by type. That's fine too. Again, whatever works for you to get it organized. The big rule is to be consistent. So let's move on to the next one before we do this demo, because we can do them both at once. So then after I get that first question moving, people are like, all right, I built my project, I've got the structure that works for me, but then what do I do once I end up with still 100 files or 200 files in my project? You know, I've got all these different features, and some of them are related, but not really. I just want them all to plug into the same UI. Well, that's where modularity can really help you out. So Angular has this great modularity feature. It allows you to create iterative development, meaning you can roll out a feature over a year, maybe once every 2 weeks, and not change much in your existing code base, just add in new code. So you add a new module, you plug it into the main module, and it just works and shows up. Wouldn't that be cool? That'd be great. And you can create reusable components. So anytime I create something in my apps that I want to reuse across multiple apps, I create a module out of it. So what's better, one monolithic app with thousands of lines of code or reusable components? You can assemble an application this way. So how do you do that? Well, first you got to understand what modules are. And modules are containers of these related features. So it's a feature area. You're building an order entry application. Maybe you've got like an admin feature to fill in the admin information. Maybe you've got a login feature for security. Maybe you've got another feature for entering customer information, order history, sales. All of those could be different modules that you work on at different times. And they can depend upon other modules, because you might be thinking, well, that's great, but I want them to all depend upon the same data services, because they're going to call the same XHR calls down to any web service that I have, like maybe Web API. Well, that's okay, because a module can depend on another module. So you define a module like this inside your HTML. You're going to have one main module. There's going to be a root module that runs the entire app. We'll just call that module name here. It could be, my application, my customer app, something like that. And then inside of that module, you're going to have things like configuration for the module and routes, so you know where to go for all the screens. Each module has its own views, so all the views have to have routes associated with them, so when somebody goes to that URL or your application navigates there, it loads that view. You might have filters in there for filtering out data. Directives that you might have written, or maybe you're pulled in from, like, again, Kendo or Bootstrap or some other library. And you might have these things called factories and services and a bunch of other stuff inside of your application. But basically, it's a self-contained unit for all of your views and controllers and all the supporting members for that feature. So for example, you can have different kinds of modules. We mentioned a couple of these already. Like, I have 3 breakdowns I do for modules. There's what Angular features do I need to add into my app? Angular itself is modular. When you pull down Angular, you don't get everything. You get the core Angular.js. If you want animation or routing or anything else, you've got to pull in that module. Here, I want to have routing, so I pulled in ng-route. The second category is custom modules. This is where I put my modules that my team wrote. Some of them will be common that I use across multiple projects. They have things in them like logging or like busy signals or things like that. And then you've got the third-party modules. If you're plugging into Bootstrap or Breeze or Kendo, you want to pull in those modules too. If you don't know what Breeze is, we'll be looking at that shortly as well. So let's say I'm building a modular app, and the first thing my team's doing is I've got one person working on layout. That's cool. So I could create a layout module. And that person's working off there and doing like the sidebar and the top nav and kind of just getting that whole look and feel working for the layout. And then I've got another person on my team working the dashboard. They create a module to do that. So it's the dashboard with all the little things that my business team wants to look at. Both of those will be dependencies for my main app. So when they're ready, I just plug them into that screen we just showed a minute ago. I plug them into the main module, and they'll just work. And maybe they got reusable widgets because I want to have a consistent look and feel throughout my app. So I could have a widgets module where I wrap up all of my Bootstrap UI stuff. Now, all of those are going to have to share some things. There might be some core configuration that I need for all my modules. So I then can have all three of those depend upon some core module. And then I've got third-party stuff and stuff my team wrote, like UI Bootstrap. I want them to use UI Bootstrap for my UI, so core will depend upon that. I've got a common module for like logging and for talking to local storage. And then when a new team member comes along and I say, oh, here's a new job for you. Go work on the Avengers module. They can work on that now, and I can just plug that in as soon as they're ready. Just make it a dependency of the modular app, and it fits just nicely. And then if I want to do other stuff like pull in Angular features, I can do that too. So you can see you can build this hierarchy of module structures to show the dependencies that you need in your application. So let's take a look at an app that I broke apart to do that. And again, all these demos are available to you. I think I killed that one. Let's go over here. So I closed in Visual Studio, but we'll look at it over here for a moment just to see, because the structure is what's important. And it's not working. Or we can just open up the other side. So here we go in the modular folder. Actually, I'll show you over here, because I want to be able to zoom in nicely. Out in GitHub, under the ng demos folder, you'll see a modular folder right here. This is the demo we're looking at. And underneath the app folder is where all the modules live. So right there, we've got an Avengers folder. That's going to be that Avengers feature we just saw. So we'll look at a list of Avengers in there. And then we've got a common folder, which has got some basic things like logging in there. And then we've got our main application. So here's my main module. If you look at that here, you can see my main module is very simple. My main module where it doesn't have any functionality, it just says, hey, you know what? Bring it all together. Give me this and this and this and this and this. It says, give me those four things that are at that top level. I need the Avengers and the dashboard and the layout. And oh, by the way, I need the widgets too. So Angular is going to say, all right, I'm defining this app called modular app. Terrible name. And I pull all these other modules in. And notice my naming convention I used in this one, just to show that they are sub-modules. You don't have to do that, but it was kind of nice in this case. And that's the entirety of that module code right there. So then let's go ahead and look at the Avengers. In this module, I've only got a couple features. If I had more, I'd create folders for them. There I've got the view for the Avengers. Then I've got Avengers.js, that's my controller. And then I've got two really important pieces. I've got the module, which I named there Avengers Module.js, to show you what does this module do. So I look at that one, and you notice it defines a module, which also depends upon a core module. So the sequence happening here is Angular is going to unravel this for me. Angular is going to crank up the main module, which sees, oh, I need Avengers. Let me go get that before I do anything else. So it goes and gets the Avengers module, says, oh, now I need to go get the core module. So it's going to go down the chain until it sees no more dependencies, and then basically instantiate all those, and then unravel them. So that's the one key piece in here. The second is, I've got a view in this module. I want to be able to create views in multiple modules and have them seen throughout the entire app. The way to do that is to create this route provider in each module. So each module has its own views. You'll notice here, I've got this get routes, And in there, I'm defining the URL Avengers and saying, when you go to that URL, go to this template called avengers.html. Each module defines its own route. And what I do is I use this little service I created in a common library just to make the lines of code simple, called a route helper. And I pass in to a function called configure routes, whatever routes I have. And as the module unravels itself, the main module in the end, which is the guy that runs the whole thing, bootstraps it, will then say, okay, every individual module is responsible for registering its routes. Now that the app's going to run, I'll know about all of them. This way, there's no interdependency of routes between modules. The other option is you could just define all your routes back in the main module. The advantage of that, the pro of that, is you've got all your routes in one place and in one big long file. The disadvantage is every time you add a module, you've got to go into that one file and keep adding to it. I like this particular technique so each person on my team can work on what they're working on without having to affect anybody else. So there's two ways of doing that. Great, so now we've got that Avengers module set up. Let's go see what the core has, because layout is the same and so is dashboard. Here's my core module. It's really rather unimpressive. Why do I need this at all? Well, core module says, what do I need to do? Go get all that common stuff that I need. Go get the NG stuff. I need animations and routing and this sanitized stuff so I can show HTML. And then I've got this common module, which has got logger stuff information in it. And it's got exception handling in it. But there's one other really important thing I put in core. It's called config. Every app's got it. We all hate it. But sometimes you need things like, what's the name of the app? What's the version of the app? Configure any services like Toaster that I'm using in here. Set up any providers or logging situations. Basically, anything I need to set up in my application for configuration, I do down at the core level. Why? Because all of my modules need to use this stuff. So, for example, I might put in here, where is the endpoint for all my HTTP services? What's that URL on the server? And then finally, we come down out of core, we'll have things like the common module. And this one is not specific to this project. This is stuff that I might reuse across multiple projects. So here we've got the module, and inside that module, you can see that guy is the end of the chain. I'm defining the module called common, and this is really important. Above my cursor there, you see that empty array? You need to do that. That's saying define the module called common. It has no dependencies. If I omit that second parameter, that becomes a getter, meaning it will go try to find a module called common. It will not create it. So the way you create a module in Angular is you pass two parameters to it. Tell me the name, tell me its dependencies. If it has no dependencies, give me an empty array. The way you get a module, if you need to go get something, you actually just use the first parameter. Say, give me the module called common or foo. So this is the end of the chain. It says, what's in this module? I commented it up here. We've got logger and spinner. And I've got some basic configuration stuff in here. And if we go back out, we can see we've got features like this logger guy down there, which has features on it like, notice the above the fold. When I open my file, I can see what the logger exposes. It's got an error, info, success, and warning, and a log method. Makes it very simple. I don't have to know what the details are again. I know, just by looking at this, that I can call logger.info, and I'm going to log information. I don't have to know how all the details are actually implemented. And one last thing that's down there is you'll see the route helper. So that thing that we used in all the other modules to define the routes, there we go. That's right here. So in the end, your modular app isn't all that large. And if you want to run this on your own, I've got some README file instructions down here on how you can do that and kind of get it up and running up on GitHub. Pretty simple to do. It's an intentionally small application. So the reality is, and this is important, is that when you're doing a modular application, if you're going to find 6 modules like I did, all with dependencies on each other, you're not going to do it for a 2-screen app like this. At least I hope you won't. I did that here just to show how to break out modules. You're going to do that for your 50-screen app or your 100-screen app. That's where you're going to break the stuff out. So the principles are exactly the same. And what's that break point of where you start doing that? For me, any app of any decent size, you're going to want to modularize it. So you can roll features in and out without creating tight coupling. Cool. Actually doing really good on time, so that's good. So we're halfway through these, and then kind of get to some business features now of how Angular works and things that make it a little bit easier to understand. So another thing I often get a question on is how does the data actually get on the screen? And people understand data binding in general, but how do I make the data go from the view to the controller, and then where does it go from there? How does it get all the way down the chain and back up? And oh, by the way, I've got to deal with asynchronous calls and possible network failures and promises in JavaScript. Are promises easy? Not always. So let's kind of walk through how the tracing stuff works inside of Angular so we can see an application make the data calls up and down the stack. So I think that'll help understand how to debug the code too. So we're going to go get a list of Avengers. I want to go get Black Widow and Iron Man and all that. That's going to show up in the view. Somebody presses a button on the view and says, go get my Avengers. Through the scope, I'm going to bind to a list of Avengers on the controller. Well, that means I'm expecting the controller to have a list of Avengers with actual data in it. Well, for the controller to get that data, it's got to tell somebody, please give me the data. So it's going to go call off to a data service or factory, say, hey, Mr. Data Service, go get me my Avenger data. All right, well, how does he know where to go? That's where he uses the Angular service for $HTTP. It's AJAX. It's going to make an XHR call, XML HTTP request. So it's going to go down to your server on Web API, Node, whatever, and it's going to hit a web service. Your web service will then go get the information, and in the meantime, your application is still singing along. It's asynchronous. Your user can do what they want on the app unless you force them not to with some kind of modal. And then your application is waiting for it. So we've left Angular by the time we got out of the data factory. The data factory made that call. The code's kind of off there running and waiting. How do we get that data back? Well, that's what we need to handle with promises. There we go. So that data factory is going to handle the async response with a promise. It's going to say, go make this call. When you're done, get my data back. And then after it gets the data back, that's when the controller is going to go get that data from that guy. So what does a controller do when it gets the data? Because if you've done any Silverlight or WPF with asynchronous programming, one of the issues you may have run into, and it's the same in the browser, is that if you're running off on a background thread, basically, getting your data, because when the promise comes back, you need to know whether the data changed. Let me say that again, because it's real important. The data comes back from an asynchronous call, a list of Avengers. You need to tell Angular, hey, I got my data, so it can do its data binding thing and show it on the screen. Otherwise, we'd have to go manually through every field and look through the array and pop them on. This is where there's an internal feature in Angular called the digest cycle. The digest cycle happens a lot whenever Angular thinks something has changed. And it's got ways of being smart about figuring out when stuff changed. Like when you change a field inside of an input, it knows something changed, so it's going to run its digest cycle to make sure everybody's in sync and data binding works. But it really can't do that when it comes back from a promise unless it knows that a promise returned. Well, the good news is if you're using $HTTP, because that's an Angular service, Angular knows that's its own service. It knows when the promise returns, so it also triggers the digest cycle so that when the data comes back, your controller's new data will just show up on the view. So this is how the whole digest cycle works with promises really well. If you've ever written Angular without $HTTP, maybe using some jQuery AJAX calls, and the data didn't show up when you got back, that's because the digest cycle didn't know about it. Angular doesn't know what jQuery is doing. You're using that for AJAX calls, it's not going to know when the data comes back. It doesn't mean you can't use jQuery. You certainly can. It just means when you get the data back, you're going to have to invoke the digest cycle yourself. So instead of doing all that yourself, the easiest way to do it is just use $HTTP, and you can make your calls. So if we look at kind of how that works, I'll minimize the browser. And let's go back over here. So here is the Avengers app that we were looking at. And we can see a bunch of Avengers on the screen. And I'll go back to the dashboard. And I must have a bug there. We want to go to Avengers. So before I go over to the Avengers screen, let's go ahead and open up the code over here. We're going to debug this through Chrome. And we'll make that a lot bigger. Whoa, that's really big. And I've got some breakpoints set up. So let's say I go to the Avengers tab. When I do that, breakpoint's not in the right spot. That's why. Let's go over to the Avengers controller. And inside of here, the first thing it's going to do on activate is it's going to go off and call this getAvengersCast. Well, that's a local function down here. So it's going to jump into there. We'll set a breakpoint there. And notice it's calling off to a data service called Avengers Data. It's going to call internal function and saying then. Then is a promise. It's saying, go make that async call, and when you're done, come back and give me the data. So that line 35 is the call out for async. Line 36 is when it gets the data back. But let's go inside of Avengers Data now, and let's see what happens in there. So here's my data service. Let me move that down. Now we can see the call to getting the Avengers. Where are they? Oh, there they are. That's going to call off using $HTTP, and then when it comes back on a promise from the web service, I'm going to get back this data, which is in a really nasty structure of data.data.data.results. I don't know who designed that. I think it was me. So we're going to make calls out from the controller to the service down to the web API, and we're going to try to watch it come back. So let's try to hit that. There's that wonderful breakpoint that I don't know where it came from. Okay, so here's my activate. The page is about to activate, and you can see I'm going to call this promise there. We then should come down to, actually, this is the breakpoint I wanted. I don't want those. We're going to call in this getMMA, so I'm going to let it run. Now it hits this local function called getMMA, and when I get that, it's going to go off and hit this other service. So now it should not hit breakpoint 29 yet, on line 29. It should go off to the service first. So when I do that, notice it does. It goes over to the data service, and now it says, all right, go off to the network. Now before I make the network call, let's go over to the network tab, and let's clear out all the calls. Let's come back to the sources. Now let's make that call and see what comes back. So now I made that call. There's a breakpoint I didn't know I had. Sorry. Ignore the man behind the curtain. Now the data call has come back. So it should have made a network call, and if I want to check my data results, let's take a look at that. Come on, hover. Let's see if I got any there. There we go. So we've got my data, my 200, and I go over the network, and you can see I got some images, and here's my get, and there's my response. There's all the data that came back for Marvel. And now that data is going to walk itself back. The next step should be get out of the factory and come back to the controller. So I hit F8 again. Now I'm back in the controller. And in my then, there's my data. So there's my 7 objects. I'm going to set that to vm.maa. That's the array that's being bound to my view for my controller. And that array right now has 0 elements in it. But once it gets set, it will have elements. And notice, all I have to do is get the data, and that's it. I don't have to call that digest cycle thing I was talking to you about. Why? Because Angular knows it came back from a promise from an asynchronous call because we use the $HTTP. So now I hit F8, let it run, and then I get my Marvel data over on the left-hand side. So the debugger in Chrome is really helpful for doing this. You can do this in Visual Studio too, but it's nice to go back and forth to kind of watch the traffic as you do this to see kind of what do those chains look like. So if you're kind of getting used to how promises work and kind of tracing the data calls, I highly recommend setting breakpoints both on the call out, like right here, and then the call back in to kind of watch what happens and watch the network traffic as this unfolds. So again, a common mistake is the data comes back, nothing shows up on the screen. That's because the digest cycle didn't kick off, which then I'd have to call myself. And that would only happen if you weren't using $HTTP. Cool. So another common thing I get a lot is, well, how do I implement exception handling for all of my Angular JavaScript? Wouldn't it be nice if I had one way to catch everything? Now, there's going to be times that you're actually going to want to have single exception handlers for a particular case in your code, but it'd be nice to be able to have one place to catch it all, especially during development, that allows you to log messages. So one thing I do is anytime I'm in development mode, I configure my exception handler, the code that we'll look at, to do 2 things additional that I wouldn't do in production. One is I show a little toast of the error as things happen. It's kind of instrumentation. That way it's in my face and popping up. Second is I write it out to the console. Now, some people say, well, writing to the console is enough. Well, that is enough if the console is open. But sometimes I run my code without the developer tools open, and if I do that, the toast makes it right in my face. So it makes it easy to check these kind of things, and it'll catch all your exceptions for you. So you can do things like the toast I mentioned, or log into the console, or do remote logging. Log things off to some web service where you're actually tracking it in an event sync. And you can have different modes for debug and development. And basically, it just gives you a consistent feel so you can write this one module that contains your exception handling and then use that across all the projects. The cool thing is this is actually really simple to do. There is a service that we can create called an exception handler service. Angular already has it, and they have a technique called decorating. You take their existing service and you decorate it with your own features, which means you're not replacing the features they have, you're adding on to it, you're extending it. It's a way for you to add on your own. So they do their own exception handling, and then you say, I also want you to do this and that. And the way you write that is I might have a module. I call mine my common EH, my common exception handler. And inside that guy, I'm going to use the syntax here where I tell it first, get this provider service. The provider service is how I decorate. So again, it's got money. It's got the dollar sign. I go get the provider service. I use the decorator on the exception handler. And then once I've got that, this function I called extend exception handler, that's a function I write. I can do anything I want there. So inside of my function called extend exception handler, I'm going to do things like logging. Let's take a look at that guy. We can look at him over here. Actually, let's look at him right in the browser. So in this module demo, we've got this exception handler JavaScript right over there. And there's just not a lot of code in it. So this guy has got that code up top for my exception config. And then here is that provider functionality that I mentioned. So first, I create the provider and I decorate my exception handler. And I'm saying for that exception handler, I'm also going to need this delegate, this exception config, and this logger. Delegate is a thing built into Angular to help me do this. And then the exception config is so I can allow somebody to set up for this exception handler. Maybe there's a message you always want to prefix every error with. For this app, for example, I like all of my applications to have a prefix of the name of the app before every error. And that's different in each app, so therefore I made a configuration. And then I have this logger service that I use to actually log out information. So here's my exception handler. It's an entirety of line 33 down to 45. So a little more than 10 lines of code with some comments. And here I've got an app prefix. That's my app prefix I go get out of config. Saying, go get that. Anytime an exception happens, this code's going to run, get my prefix. And then, notice on line 41, 2, and 3, I'm just formatting the message and sending it to the logger. That's it. And Angular will catch all these errors and then put a nice red box up inside my application anytime an error occurs. And the box will look something like this. Oops, if I get rid of all my breakpoints. Easy way to do that is close this guy. So the boxes will look like this, but they'll be red with the error message in them. It's just kind of in your face. But it allows me to do that, and I don't have to just log it to the screen. Again, I can console log it, or I can send it off to a web service, or stick it up inside of Azure Mobile Services for some kind of a log, maybe in table storage. Cool. So that's a pretty common business case that you might use. So the last 3 tips are a little more richer cases of data. Sometimes you do something more than just getting data. And by that I mean you might just not want to get the data. You might want to share it across multiple screens. You might want to know when data's changed. You might want to have an order entry screen where you log a bunch of orders and details and everything else in one place, and then send a change set back of all the inserts, deletes, and updates in one shot. Well, once you do that, try doing it just with straight HTTP. It's not easy. You've got to manage relationships and change sets and all sorts of stuff. So that's where I use a library like Breeze. Breeze works really great with pretty much any back end, but it works even better with ASP.NET. So in a nutshell, what Breeze will do, because this is not a Breeze section, but it's really great with Angular, is it allows you to get beyond what HTTP does by default. And it uses $HTTP to get to the back end, but it lets you track changes, cache data, share it, manage change sets, and even write local queries. So once you get your data to the client, it'll cache it for you if you want, so you can write a link-like syntax in JavaScript to get to that data. So if you want multiple views of the same object, for example, I mentioned before you might have customers on every page. Let's say we've got Julie Ralph over here on her page for her profile. We've also got her on the page for all the speakers in our event app. She shows up in the session list too. Oop, there she is again, another page. So we've got her all over the place. What happens if we get Julie's information? We share that across all the places by using Breeze. It does it for us behind the scenes. You don't have to do anything to make this work. You just use Breeze to get the data, and it remembers anything you've got. So what about changes? Let's say we change Julie's name from Julie to Juliet. Well, once you do that, because we're caching the data, all the other places that had it now also get that information. And that's because Breeze cached the data in one place, and it allows the data binding to work that Angular just does so wonderfully to update every place that's using it. This is super cool, so when you make changes in one screen, you don't have to go and talk to all the other screens and send messages out across your entire application to get it to work. Other things it does, like telling you if anything's changed in your application, so you can set a little star to say, something changed about this entity. Why is that cool? Because maybe you want to enable or disable buttons, like saving and canceling and deleting, based on if there's changes. Maybe you want to not let the user leave the screen. Maybe you want to start some validation logic. So once you get that data, let's say I go to this page to get session data. Then after I get that data, what Breeze is doing under the cover is saying, ooh, I have speaker information. I'm going to hang on to that into a little bucket called speakers. And you know, I've got other information too, like time slots. So I pull that out of there. I see there's rooms. So I'm kind of hanging on to those for you. And then I've got other information like, you know, the tracks. And then the session information themselves. Gotta love gratuitous animations, huh? Had fun with that. So then we put all this together, and Breeze is hanging on to this for us. So then, let's say we have another screen where we have a drop-down list of rooms or tracks or time slots. I've already got the data in Breeze. I don't have to make another call to the server. That's the kind of stuff I want to cache. I don't want to have to go back and forth to get stuff that I should have. I don't change the rooms at TechEd a whole lot, right? So that stuff I want to cache up here. I don't change the tracks. They don't change. And if they do, I just ask the server to get me new data. So let's take a quick look at something that Breeze does for you to get beyond those basics. So this is a demo called To Do Zumo. Zumo is Azure Mobile Services. So just to show not hitting against Entity Framework at this time, although I have a demo that does that too, because Breeze can hit against anything you want. It might actually be running. Let's see. Here it is. So here is the app we're going to be showing. Let me reset it. It's actually hitting the server. And notice I got some messages down here. Whip has been stopped, and I cleared the whip stash. What is a whip? Why is John whipping us in the morning? Whip is work in progress. So as I'm changing this stuff, it's showing all the changes down here just to alert me to see what's happening. So it's a list of to-dos. And this list of to-dos, as I'm typing things in, I'll enter a task in here like give John a 5 for his eval. Subtle hint messages. So I add that task in there. Notice now I got a message stashing those changes down here. It's checking out all my changes. Now, let me go ahead and we'll add another one. Just add something like that. Now, let's mark this one completed. We'll actually show the completed just so we can see them. There they are. And let's delete one. Let's go ahead and delete this thing called another. Now, down below, well, let's change one too. Why not? Let's change, get some sleep now. Down below, which you might not have noticed, is right there. 7 items. That's the change set. We added 2, deleted 1, modified 1, all the stuff in there. We have some completed ones too. There's 7 items total. I'm showing the change set here. None of this has gone back to my database, my source of truth. It's not actually hitting that side yet. Breeze is tracking not only that there were changes, but what kind of changes there are in a change set. And on top of that, it's doing that for free for us, but on top of that, it's also, let's see here, going off to local storage and saving that change set for me. So if we run off to the resources, we can look inside of local storage, and you're going to see this thing called whip there. Let me copy that, and let's go ahead and open up Notepad. We all have to have Notepad in every demo, right? And boom, and that's the most wonderful font ever. Let's change that. We'll go up to 22. And inside of here, you can see all the data. You can see that get some sleep. We've got original values in there. We've got changed values. Breeze is actually saving off only the change set. So the ones that didn't change are not in here. Saving to local storage. Why do I care if it's in local storage? Because sometimes we close the browser or our machine crashes or something like that, and we don't want to lose the user's information. So now, not only is it not saved in Zumo in the cloud, in Azure Mobile Services, but it's saved in local storage in the browser, so if I accidentally close the browser and come back in, those changes are still there. And then, when I come back to my app, I can then sync those up with the server if I want to save them, or I can refresh and basically pull other to-dos down from the cloud that other people might have had. So somebody else hit this, refresh would pull those back down for me, or I can wipe them all away and reset. And Breeze will do all that kind of stuff in the background for me. So that's kind of the basics of Breeze. Let's look at some more advanced stuff that's really cool that Breeze can do. So I love this piece. When I do validation, people always ask me in Angular, how do you do validation? Do you just stick the HTML validation attributes in there? And I say, no, I don't. Like, wait, you don't like HTML? No, I love it. But there's some problems with HTML validation. And let me explain what those are and why I think there's a better way. So where are you going to validate your changes? You want to do that on the client for a better user experience. Validation happens on the client to help the user out. For here, I'm typing in an email, and that email is not valid, so I want to tell the user now. I don't want to wait for them to press save, and God forbid for it to go all the way back to the database and then come back and go, nope, you didn't put a valid one in. I want to do that right here on the client. So we can do that pretty easily, but I like to use something called model validation. Not HTML validation or client validation, but model validation. So where does that logic belong? You want to validate the HTML. If you do that with those attributes that come in HTML5, you're going to repeat that same validation in many places. So let's say I've got an email field for a customer, and that shows up in 5 places in 5 different screens. I now have to put the required field and the regular expression for HTML5 on every single input on all 5 of those screens. Well, not so bad, I guess, right? But you get a large application, you're starting to copying and pasting, and somewhere along the lines, you're going to miss that validation, especially if you change the rule. And it doesn't handle model validation changes, meaning what if somebody changes the data into JavaScript through some background thing that you're doing or through some business rule? It's not going to get caught because you didn't change it through the HTML screen. So I want to push that validation down to the one place on my client that I have one customer email. That's in the JavaScript model. If I validate it right in the model, every place on the screen will always be caught, and I don't have to put that code in 5 places or more, and it catches all my JavaScript changes. So we want to do that in the model. So we might have a screen like this where we've got a title, which has got a required field. We might have a drop-down that tells you have to select a valid value here. So here we've got this thing called a data z validate. Data dash is just an HTML5 standard for any custom attributes. So you can say basically z validate on this field, and it just knows that that field is required. So I'm not using HTML5 validation. I'm just saying there is validation on this field. Please use it. This means I could have 5 validation rules for this field, and it will invoke them all. It could be required, minimum length, some other custom rule that you do. So this is a Breeze directive that I can include in my project, and it just works. And you get a lot of this stuff for free. If you're using Entity Framework, Angular and Breeze, when you make those calls down to the database to get your models, it's going to know stuff like required fields and minimum length and maximum length. It just brings that along in the metadata, the basics of validation. And then, if you tack on this validate attribute, it'll automatically put these little title is required next to your screen. And it'll also put the asterisks next to the fields for you, which, of course, you can customize your CSS to do whatever you want. So that did the required field for me, and it also put the asterisk there. But what about that missing time slot? Well, we get that metadata out of there, and you can see you got max length, and you could also have min length. But you've also got custom rules. So that drop-down list, it's not null, so it's not a required field really, but I have this thing inside the drop-down list for time slots that's not a real time. It's a select a time slot. It's the default I want in there. I don't want the user to be able to save when that's selected, though. So I had to write a custom rule to handle this. And I did that in a little bit of JavaScript. So what I did is say, okay, anytime you're selecting a room, a track, a time slot, or a speaker, because they all have this same thing in common, go ahead and create this rule to make sure I've got a validator. And I went through each one of them and said, all right, get the property called what? Room, track, time slot, or speaker. And in its validators, push this reference validator, which I created, called require reference validator, into it. So in just a couple lines of code, I now told Breeze about a new rule. And the logic in that function is whatever you want it to be. Make sure it's not equal to -1 or whatever value or the text that's in there. And then you just push that rule into the collection, associate it with a property on a model, and then every place it shows up, you get validation. So I want to leave you with this big thought on that topic, and that's validation on the server is mandatory. And by no means am I saying don't do it on the server. Always, always, always been the server. But on the client, it's a user experience. And the cool thing is, it's really easy to do when you're using Angular with Breeze with Entity Framework. So let's take a quick look at that. All right. So in this demo, we're running this application, and this is actually a live demo up on a website, and the URL, again, is in the demo code. But up here, I've got a session, and in this session, you can see I've got this title up here. Well, let's change this title, and let's just add a new field to it. Let's just say this will be Angular Rocks. And when I do that, notice I've got this change flag right there, this orange guy on the top. Now, let's go back a little bit, and let's delete that. As soon as I did that, everything changed. And yes, I like The Princess Bride, so I changed my CSS to say that. So you can change the look, the feel, the text, whatever you want. But to get here, there's no magic. Let's go ahead and just prove this. Let's right-click and go to Inspect Element. And then down here, inside my code, let's take a look at that input. On that input, you can see my model, and then over on the right, you can see data-z-, and it's going to scroll for me, validate. That single attribute is what's adding that validation feature. So then, all I have to do is get that data, and then anytime I have some kind of required field, like here, boom, that's inconceivable. What are you doing? That guy's inconceivable. You're out of order. He's out of order. We're all out of order. And I've got all those issues. Now, if I try to save it, the user still can press save, boom. Breeze is also letting me see a consolidated list of all the issues, too. So it gives you all this validation for free out of the box. And again, you can write your own validation rules, again, very simply. They can even be asynchronous if you want to. It gets even more fancy because let's say I go to sessions and I want to add a session. Let's say I'm in the middle of adding a session here and I type in foo is the name of the session. Notice there's no error messages for the rest of the stuff. Why? Because it would really annoy my user, in my opinion, if I had 5 different toasts hanging on the screen as soon as I create a new session saying, here's all the stuff you didn't fill in yet. That's really annoying. And I've seen forms like that. So when I do a new one, I didn't turn off validation. I just told it, don't show it to me until they try to save. If I try to save, it still catches them. It says, hey, wait a minute, don't be tricky. And it catches all that data for me. So it's just a nice way you can actually turn that on or off with a single flag in Breeze to say, you can actually have it show up on by default, or you can tell it, don't show up until the save actually occurs. And then I can cancel out of all of that. So here's my favorite demo and the final tip. And I do this a lot because I feel like a lot of users are left in a state where they get to a screen and they have to lose changes somewhere. And risking that loss of changes is a frustration. I bought something off of a large website the other day, and when I started filling out the information, the whole thing on the website just didn't work. It said, oh, you had an error. Started hitting the back button. Things had to reload. Nothing came back. And I had to do the whole order all over again, and I didn't have time, so I didn't do it. That company lost money because I didn't have a good experience. You don't want your users to have a bad experience by losing changes, and maybe the browser crashes, or I've done this before. You go up to the tab in the browser, and you click the tab and close it by accident when you're actually trying to select it. Oops. So there's some options when dealing with saving changes, and we can do a lot of things. When the user leaves the page, you just lose your changes. That's a great user experience. Go away and never come back. You cannot leave. I see this commonly out there. No, sorry, you can't leave this page, you fill this in. And then you're trying to figure out what did you not fill in. And you can't figure it out because the messages are terrible because they didn't use the validation that I did, right? So then you're stuck there with annoying pop-ups all over the place, trying to make you buy, vacation time in Tahiti. Or you can auto-save as the user types. Every time you press a keystroke or leave a field, you send it down to the database. Oh, that's great. Now we have network traffic going crazy. And what happens if you try to save an incomplete object? You don't have all the required fields, so the database isn't going to let you save it. So, do you give up? Well, that's all the time I have for today, so I hope you had a good... No. At this point, use something like local storage is a great option to do, or Azure Mobile Services would be another great option. Save the data somewhere so you can recover and make it a good experience. Your users don't care. They just want it to work. So let's take a look at how we can use local storage to do this. And then I'll show you how it made it really easy for you. Because there's a link right to the library that I'm using to do this. So here's the source code for this application. It's the one we were just looking at. Not that one. Yes, my fingers are not working. Come on, mouse. Chrome. So it's this application here. Let me reset this guy. So I'm back on my main screen, I'm in my sessions, and I'm doing a bunch of things, and let's say I come across this session again, and I'm going to change some values here to say best AngularJS session ever. And there he is. When I did that, notice a little box down the bottom corner says updated whip, right there. Gotta love those whips. Work in progress. That's just my little message to me to say something changed. Breeze told me something changed. I'm going to do something with that data. So what happened? I changed this thing to a star up here, and I also updated this guy to be orange, because orange is cool. And then I can say number 1 next to it. There's one thing in work in progress. So now, let's say I get a phone call because I can't finish what I'm doing here. And let's even make it in a bad state. Let's make the track be select a track. It's invalid. I saved it back to WIP. And let's say go over to speakers. Uh-oh, did I lose my changes? Well, let's go back to the sessions. And when I click into that guy, notice the session title still is SECA, whatever SECA means. Boom. Again, this is public data. But I click into that, and it's not SECA. It's the data I had. What happens if I close the entire browser? Don't do it. I did it. I come back up. I click right on that same URL. Boom. It's all back. How's that for user experience, right? That's cool. So, where's the magic? I actually have a bunch of gerbils inside my computer, and they write really quickly. Over here in the resources and local storage, you'll see I've got this entry right there. See, they're clapping too. They've got this Breeze whip thing up there, which is saving off a JSON object, which is just the change sets. The same thing that other app was doing, but in a different context. So I can save off just those changes, and there's a GUID there for the actual change I made. Now watch this. We'll leave that resource open. When I cancel this, watch what happens on the right-hand side. That guy became an empty array, and the other one disappeared. So it's cleaning up after itself, and it's adding things to itself. And over here on the left-hand side, if I could figure out my left and right, I no longer have work in progress. So let's add a change real quick again. Boom. Let's not save it. Let's go back to sessions. Now let's add a new session. Let's call this thing foo, because foo is awesome. Let's not save it. Over on the right-hand side, we can see 2 entries in there. The top entry is a summary. What's that summary used for? That's for this page to show me, hey, what kind of work in progress do I have, and what is it? One's modified, one's added, this is the dates. Just give me information to show the user, so I can actually select right onto that guy. So there's 2 ways back in. I can go right to that session, or I can just click on it here. And now it shows me the validation errors. So all of that set up pretty easily. And the rest of these slides are really just for your notes afterwards for the features. Kind of how it works. Now, how do you get to there? You'll see the code in these slides. And again, you have these. You can download off the website. It shows you how you can export the data through Breeze. One line of code to export it, gets it out to local storage, and then you can import it back in with a couple lines of code right back into Breeze. It takes the JSON out of local storage, pulls it back in. And then finally, we tell the user using the asterisks and the colors. The last bit is just showing you where all this stuff exists. So when you use these patterns, and these help me a lot in business apps, you can get all this stuff from these links up on the screen here. And definitely check these out. All the demos are in the upper left-hand corner up on GitHub. They're all free. And I hope you guys enjoy this. If you have any questions, I'll be sticking around a bit. But thanks for coming.